Our next topic is how to calculate the mean and the standard deviation for a binomial distribution. And these are two relatively simple formulas. They are, I believe, on your formula sheet that you'll have for the exam, but they aren't too difficult to memorize. First up is the mean, and we're going back to our notation for using mu, the Greek letter mu, to represent the mean of a distribution. And the mean of a binomial distribution is simply equal to n, the number of observations, times p, the probability of success on any one observation. And then the standard deviation, which again we're using the Greek letter sigma to represent, is equal to the square root of np times 1 minus p, again where n is the number of observations and p is the probability of success on any one observation. So I believe I went through the example of the engineer who was looking for the bad switches in the shipment of 10,000 switches. So let's use that as our example to calculate a mean and a standard deviation. So in that example, n was equal to 10 because he was pulling out a simple random sample of 10 switches and testing all of them. P was equal to 10% or 0.1 because he knew that 10% of the switches were bad. And so that's all the information that you need for any binomial distribution to calculate its mean and its standard deviation. So let's do the mean first. The mean, again, our formula is n times p, so in this case it's 10 times 0.1, which of course is just 1, and that should make sense. If we're looking at a sample of 10 switches, we know 10% of them are bad, we would expect on average to only find one bad switch. For our standard deviation, we'd take the square root of n times p times 1 minus p. So it's going to be 10 times 0.1 times 1 minus p, which will be 0.9. Extend that square root. And so this ends up simplifying down to the square root of 0.9, which calculates out to be approximately 0.9487. So that's how you use the two formulas. They're relatively simple to work with.